Hey Pre-Calc students, Mr. Mitchell here. We're going to take a look at finding zeros of polynomial functions. There's some information up above here that take a look at and read on your own in your notes. But we're going to find the number of zeros, determine the number of zeros of each polynomial. So we're not actually finding them. We could actually do that. But they're just asking to determine the number of zeros, all types. So this is x to the first. It has 1 0. This is x squared. It has 2 zeros. X cubed has 3 zeros. X to the fourth has 4 zeros. Now, these could be real or imaginary. We're not declaring that based on this. We're just determining how many there are. So when you solve this, you should get 1, 0, 2, 3, and 4. Depending on the highest power tells you how many zeros. All right? So next, find the rational zeros of each polynomial using the rational zero test. Rational zero test has become a little bit outdated because of a calculator, but we can take a look and see if we can determine the rational zeros, and then we can use synthetic division to find out what the zeros are. So based on this, you make a fraction out of the constant and the leading coefficient. So this number, put all the factors of it on the top. So it's just 1, so it's plus or minus 1. That goes on the top. And then on the bottom, you put all the factors of that. So that's just 1. So your zeros could be 1 or -1 in terms of rational. That doesn't mean you can't have any square roots or you can't have any imaginaries, but these are your rational zeros. So then what you would do is do synthetic division. So you put 1 in the box. You could do -1 first, so we're going to do 1. So then we have 1, 0, 1, 1. So we're just doing synthetic division like we learned in a couple lessons ago. So you bring down that, multiply, add, multiply, add, multiply, and add. So what does that mean? 1 is not a 0. Well, then you stick -1 in the box, and you start over since we didn't have any zeros there. I'll bring down my first number, I multiply, put those together, add, multiply, add, multiply, add. What does that mean? That means none of them are rational. This does not have any rational zeros. Okay? But the concept is we're checking to see what are potential rational zeros. So that's all we're going to do with these next couple. We're not actually going to try to find the zeros, but I'm showing you the process. We will use our calculator to help with this process. So here's some rational zeros. I look at the 6, and then I look at the 1. So I'm going to go plus or minus 6 on the top, plus or minus 1, because 1 times 6 is 6. And what else multiplies to 6? 2 and 3. And then what goes on the bottom? What are the factors of 1? Well, it's just 1 times 1, so you don't really need to worry about that. It still has a bottom of a fraction, so you need to account for that. So these are the 8 zeros that are potential rational zeros. They're not all of them, because I only have 4 zeros. So all 8 of them can't work. So if you're doing this all by hand, you would just pick a number from this 8, positive 6, -6, positive 1, -1. You pick one of them, do synthetic division. You're looking for a remainder of 0. Okay? Our calculator is going to help with this process, so we don't have to just guess and check the whole time. But it's helpful to know how to make our list without a calculator so you can do it. So what are the factors of 3? So plus or minus 3. Plus or minus 1 goes on the top. How about 2? What are the factors of 2? Plus or minus 2, plus or minus 1. So now I need to list out my zeros even more because I got some different things. You don't have to put plus or minus on the bottom. I didn't need to write that. So I got plus or minus 3 over 2. And then I have plus or minus 3 over 1. And then I have plus or minus 1 over 2. And plus or minus 1 over 1. So these are all possible rational zeros. I'm not actually finding them. I could graph it and do it that way. But I'm just trying to locate my possible zeros. And if I were doing it all by hand, I would put one of these numbers. I would probably start with my integers I'd probably do 1, -1, 3, -3, and then venture into the fractions. I do have 3 zeros here for letter C. So one of them is probably going to be, or 2 of them could be imaginary, one of them could be real, or rational, I mean. So you just have to do the rational zero test to check and see what are possible zeros. Okay? So it says find all possible rational zeros of the following polynomial using the rational zero test. Then find all real solutions. So if we made a list, and I'm going to use my calculator here in this problem. So I'm looking at 12 and I'm looking at 10. Let's just make our list. So what are all the factors of 12? Plus or minus 12, plus or minus 1, plus or minus 6, plus or minus 2. We've got a lot here, huh? Plus or minus 4, plus or minus 3. And that's all over. Plus or minus 10, plus or minus 1, plus or minus 5, plus or minus 2. So you can see that's a huge list of possibilities. So let's not just do guess and check. If this is the only method we have, then we'll have to do it. There's no other way around it. We have to just suck it up and do it, and not much we can do. But we have a calculator that's very helpful. So let's try that. Okay? So I pull up my calculator. I go to y equals, and I type in my equation. This is the equation that we're looking at, trying to find the zeros. So I type that in. And then I'm going to graph it. If I can't see it, it's because my window is a little off. So I always make my windows -10s for the mins, 10s for the maxes, and then the scale, I just make them 1. So my mins are -10, my maxes are 10, and the scales are 1. So there I graph it. Boom! So it looks like it crosses here, here, and here. So it looks like there's 3 real zeros, no imaginary. So I need to find those. So I go second calc. I'm looking for zeros, so I select option 2. It looks like it crosses at -1. If I had to guess, so this is going to be where we start. So I need to follow the directions. It says left bound. Go to the left of this point. Yes, I know it's above it, but it's to the left. Hit enter. Go to the right of this point and hit enter. And then guess near the point. Oh. That's an ugly decimal. Well, that's not going to help me. I need it to be a nice round integer or rational number. That's an irrational number. So I try again. So this one looks like an ugly decimal, so I'm not going to try to find it right now. This other one looks like it's right around 2. So let's try that. So I go to the left of the point, I hit enter. I go to the right of the point, I hit enter. And then I guess near the point, and it's exactly 2. And that's what I need. I need it to be an exact integer or fraction. It could be a rational number. So let's go back. Out of all this mess, I found one of my zeros is x equals 2. That's one of them. So I need to find the other 2. So I'm going to put 2 in the box. I do not want ugly decimals. That does not help me. That doesn't tell me what they are. So I put -10, 15, 16, and -12. We're going to do synthetic division. I bring down my -10, and I multiply. I bring down my -5, then I multiply. What did I do? I messed up. At least I caught it before I went too far, huh? So, oops. So -20 and 15 is -5. Yeah, 2 times 5 is -10. There we go. So this is going to be a +6. Then you multiply, and you get it to be a 12. And so I have a remainder of 0, which is what I wanted. So what do I got? I got -10x squared minus 5x plus 6. I'm going to venture a guess that this doesn't factor by the idea that these are ugly decimals. So it's not probably going to be factored. So I'm going to use my quadratic formula. I'm going to use my quadratic formula to try to solve this. So I got negative negative 5 plus or minus the square root of negative 5 squared minus 4 times a, negative 10 times c6. And then that's all over 2 times negative 10. And then it's time to simplify. So I should have a 5 plus or minus the square root of. If you need to do this in multiple steps, you can. You can. So this is going to be a 25. This is going to be 40 times 6. I believe that is 240. All right, 4 times 6 is 24. And then that's all over negative 20. Then I have 5 plus or minus the square root of 265 over negative 20. So how do I know if I'm done? I need to take my calculator and start dividing 265 by numbers. 265 divided by 5 is 53. I don't think anything divides into 53. So I don't think that this can be simplified. So I think this is my answer. There's 2 answers there along with x equals 2. These are my 3 zeros. I should have 3. It's x cubed. So there's my 3 zeros. Okay? So to sum it up, I need to figure out this number. I could have gotten it from here. Here's 2. If I would have started, I need to make up, remember, it's 12 over 10, 12 over 1, 12 over 5, 12 over 2. And then it would have been a 4 over 2 is really where the 2 would have come from. Think about all the possibilities. You're taking 12 and dividing by all of these. You're taking 1 and dividing by all of these. It's a long process. Calculator has streamlined it. You saw I got 2 from the calculator, which is what you're going to have to do. Honestly, in class, you're not going to have to do guess and check. You're going to use your calculator to find that. You do need to know how to make this list, though, in an appropriate way. Okay. Let's take a look at letter B. So we need to find a 4th degree polynomial that has, with real coefficients, that has zeros of negative 1, negative 3, and 3i. Well, I can tell you there's another 0 that they didn't tell you. It's negative 3i. It's called a conjugate pair. These two go together. So 3i and negative 3i. Or if you had the square root of 3, negative square root of 3 would also be a 0. If you had the square root of 7, negative square root of 7. These would be conjugate pairs. They go together. So the first thing I need to do, I need to write my zeros as factors. So negative 1 is a factor as x plus 1. So I got negative 1 and negative 1. So I got x plus 1, x plus 1. And then I got x minus 3i, taking the opposite of that. And then x plus 3i. So this is the 4th degree polynomial in factored form. But I need to multiply all this stuff out. So let's start by multiplying this out. So what's x plus 1 times x plus 1? It turns into x squared plus 2x plus 2. I'm sorry, plus 1, not plus 2. Probably should erase that. There we go. Plus 1. Put it in parentheses. Now what does this multiply out to? Well, be careful. They're conjugate pairs on purpose. It's going to turn into x squared. The inner and the outer terms cancel. So all you have to do is multiply negative 3i times 3i. You're going to get negative 9i squared, which turns into plus 9. And then the only thing that's left for you to do, you have to FOIL this stuff out. So take x squared times x squared, you get x to the 4th. Take x squared times 9, 9x squared. Take 2x times x squared, 2x cubed. 2x times 9 is 18x. Take 1 times both of them. And now you just need to put together any terms that are the same. So there are no other x to the 4th, so it's x to the 4th. There are no other x cubed, so it's 2x cubed. There is an x squared term here and here, so that turns out to be 10x squared. There are no other x's, so it's just 18x, and then a plus 9. And that is correct. There's your polynomial. If you have any questions, let me know. I will finish the video by doing those on another video.